Day 2 of 3 of the Physical Computing Workshop in Aberdeen Grammar started with a quick recap of Day 1's activities, setting the task of building a machine that can move a ball at least 1 metre without human touch. All the pupils were raring to go, and they set out designing and planning their machines, working well in their teams, and they had the confidence from previous day's session using the microbits to utilise the GPIO inputs and outputs to quickly start prototyping and building their Heath Robinson machines. Planning, discussing, sketching, measuring, testing and building came easily as the pupils communicated their ideas with each other. The inventiveness and different approaches of all 3 teams was exciting to watch. All the teams had access to cardboard, tape, pens, hot glue, as well as sensors, motors, LEDs and a suite of electronics equipment. One team even brought their own Kinects to prototype and build a chassis for their vehicle solution. Day 2 opened the pupils' inventiveness, opportunities to try new ideas, observe which ones worked and which ones didn't. The pupils were comfortable with things going wrong or the realisation that an idea might not be the best solution for the final build. The ease of wiring up components, creating JavaScript with make code's drag and drop blocks enabled the pupils to work in an agile fashion. The abundance of GPIO equipment pushed their thinking, trying large arrays of servos and motors, and they were prototyping ideas of passing a ball along their paths. Ultimately, the idea was shelved, as more simple solutions were found through teamwork and discussion. The teams worked well together. Each team member had a task to fulfill, some working individually and adding their builds to the final construction, or working in pairs on large elements, always discussing and communicating their progress through quick catch-up meetings before breaks. As the day progressed, the teams kept testing and tweaking, finding problems and thinking of potential solutions to the elements in their machines that did not work as expected, or at all. The pupils commented on how easy it was to program in the make code environment. The speed of adapting and reapplying the code to microbits was exciting, again opening up a mindset of agile development and ease of adaptation. The team building a catapult and baffle track found problems with the ball bouncing out of the track, the ball missing the target to switch on LEDs and music if successful, testing and tweaking each time they observed the frequent problems. The Rollercoaster team had similar problems. The track needed to be measured, moved, observe where the ball would stick or stop. Ramps and guides were put in to smooth the descent. The resilience of the pupils when testing and honing was a joy to see. They worked hard on their builds, clearly working towards a shared goal with planning and communication. If time allowed, the teams felt confident to add or extend their own challenges, trying new ideas, discarding or implementing their additions to the machines. It was exciting to see how comfortable the team's approach with new ideas were, after only working with the equipment for 3 days. We can see that project work like this opens up for a wide range of learning opportunities for the pupils. Resilience, creativity, teamwork and communication are the products of digital making experiences. The pupils did learn to code JavaScript to wire up GPIO devices, but these skills gave the pupils confidence and a true growth mindset to try and fail, to test and tweak in order to find solutions to presented problems. In the end, we had 3 teams with 3 completely different approaches to one brief: to move a ball at least a metre without human touch. Team Catapult created a servo-controlled launch mechanism, a measured catching hopper, a baffled tower that slowed the ball's descent, an angled ramp with a cover to stop the ball from bouncing out of the track, ending in a controlled landing that triggered a switch to light an RGB LED and play a tune on a second microbit. They showcased their machine, highlighting where things went well, where things could be made better, difficulties they overcame, and how they all felt working on the machine together. Team Rollercoaster built a long, winding track with a servo-controlled release mechanism. Once at the bottom of the track, a row of 8 motors were used to drive a platform with the ball over a distance of 80 centimetres. Intense testing and tweaking were applied to this build, giving the pupils a great sense of teamwork with contributing ideas coming from all team members. Successful delivery did come in the end, but they all agreed they could hone the build after more time. Team Sandcrawler's vehicle was designed to be remotely operated using 2 microbits to communicate with the radio function. The idea was to drive up to the ball, activate a servo-controlled jaw and trap the ball, then drive at least a meter. In testing, this worked perfectly, but when it came to the final presentation, several technical errors hindered the final showcase. But the team were comfortable with this result, as they had previously been successful. It helped them explain the problems that they had encountered and how they would overcome them if they had more time and robust building tools. Each team succeeded. Each team member stated how much fun they'd had and how surprised they were at how much they had done in just 3 days. We'd like to say a big thank you to Matthew Foster from Aberdeen Grammar for having Digital Makers CIC run this physical computing workshop in their Skills Week. We look forward to working with them again.